All right, any questions before we get started? All right, knock it off. Are there any questions before we get going? No, nothing? You saw the email about the midterm, right? Yeah, well, I sent you an email about the midterm. I don't know, like 15, 20 minutes ago? What's up?
What does a midterm look like?
What does it look like?
Yeah.
Could you be more specific?
Like I've never taken a computer science test before and I just don't know.
It would be similar to like a math test. I mean, the questions would be on like pencil paper. You're not coding on a computer.
Okay.
The midterm is broken down into two broad sections. The first section is called short answer, because the answer should be really short. Typically on a written test, especially at this stage, if you find yourself writing a lot of code for a solution to a problem, you're doing something wrong. I'm not that mean. So the first part is short answer. It'll be little questions like, write the code to do this, right? Something like, okay, here's what the input is. I want this to be out the output, write the function. Sometimes it could be like, well, here's the code, here's the input, what's the output, you tell me. And sometimes it's kind of like the reverse, where it's here's the output, here's the input, what would have to be here's the output, here's the function, what would the input have to be that? Those ones I think are fine. Then there's the next part, which is called short answer. So the answers won't be quite as short. So you might have to write like a function or something, but it's still like if I were to write the function that I know is on the test, I would write it in 1, 2, 3, 4, 5, 6, 7 lines of code. So it's not too bad. I like to design my tests to be, if you know what you're doing, you're going to ace it. You're going to do very well. If you don't know what you're doing, good luck. Not because I'm deliberately trying to affect you, but a lot of times in computer science, so okay, in a lot of courses, you look at the course average and you typically get like a nice normal-ish distribution of what the grades are. That's a good thing. Computer science is entirely different. Computer science is bimodal. That is, you have the group that does well, and then you have the group that does poorly. Is that right for you? Whatever. This would be the good side, right? Okay, there's a group that does well and a group that does poorly. Ideally, you want everyone to do well. Realistically, that's not going to happen. And if you're writing a really good test, like if I'm creating a really good test, those get separated more and more. The people that get it should have a great time. Those that don't get it, well, they're just going to show you how much you don't get it. And usually, like it's really easy to mark answers that are nonsense. Because if you go like, oh, so you just like vomit it on the page, 0. Like, you don't get part marks for bullshit, right? If you just start throwing everything in the kitchen sink on the page, well, I'll get some part marks. Not with me, you won't. You don't get part marks for nonsense. But we mark for how, so one, marking in computer science might not quite be what you'd expect it to be. Because like in math, it's like, oh, the answer is right or wrong. And a lot of people coming from high school have that mentality, but once the problems get more complex, it's not about, like obviously some things are correct and some things are incorrect. But if I'm looking at your answer, and maybe there's like a tiny little itty bitty mistake or something that makes it wrong, but I go, no, they clearly know what the solution is. Like they get it. I don't really care. Like syntax, not going to be, if the syntax is readable enough that I know what you're doing, I'm not going to care. But if your stuff is like, if your assignments are like on the wrong side, I care about that. But if you miss a parenthesis or you miss a colon, no, I don't care. What Does that answer your question? Yeah. It'll be held in here if you're in this section. If you're in the other section, it'll be held wherever that is, whenever that is. But it's the same day, so. And yes, you have different tests. They're similar, but not going to be identical. Any other questions? Raise your hand if you've done assignment 1. No, that's good. Raise your hand if you've got a really exciting weekend planned, because it's going to be working on assignment 1. Yeah, you do. Cool. You had a question?
I did actually have a question. I'm curious about how this midterm will work.
I don't know offhand, but it's on the syllabus. So I don't know. Someone look it up and get the answer. Maybe it's 20%? I don't know. What else? So I wanted to show you a couple things about the assignment, just to be sure, because there were some questions I was getting that made me think people were working way too hard. Classic mistake when you're new. The assignment, realistically, a correct solution to the assignment would be like, like 14 lines of code in total. Now that doesn't mean it's easy. In fact, it's hard to take code that exists and kind of like do what you need to do within it. So that's a very important skill to have. So I'm not saying it's easy, but I'm saying if you're starting to write like dozens and dozens of lines of code, whoa, slow down. You're probably working too hard, going down a rabbit hole that you don't want to go down. Like one of the first parts of the assignment is like check out the loading data function. If we go here, there's nothing, like you do not need to change anything in this function. If you're working on Colab, just make sure you upload the starbucks.csv file. If you've downloaded it multiple times, you might have starbucks.csv and then starbucks1.csv and starbucks2.csv. The file names need to match exactly. So if you upload starbucks1.csv and you're saying load in starbucks.csv, Python will say there's no such thing. I can't find it. So there's that. If you're not, raise your hand if you're doing it not on Colab. All right, well that makes it easy then. Cool. And what this is doing, by the end of the semester, you will know what all of this is, easy peasy. But this is, at this point, a function that I wouldn't be shocked if people could look at this and kind of get a sense of what it's doing. But what it does is it loads in the file, and then it reads all the data one line at a time in the file, and we store that information in a list, basically a long collection of those things. Yeah?
In Notepad++, where would we put like a CSV for it to be able to read it?
If you're in the same working directory that this file is saved in.
Okay.
So if you have this saved in a folder on your desktop called 161 Assignment 1, and this is in here called asn1.py, put starbucks.csv in that exact same folder. If you're using an IDE though, sometimes a working directory is not necessarily the exact same directory that the script is in. It might be above or in another directory. It depends on how you have that set up. That complexity is why I don't recommend using an IDE when you're just starting out, because it can throw you off. But anyways, so is that, you're good? Cool. Yeah?
I just have a question on like, how is like an assignment like this marked?
How is it marked?
Yeah.
We mark it for correctness. Like, if we hit run and you're wrong, we go, okay, let's go find out why. We're like, oh, well, they blew this part, marks off. They blew that part, marks off. Like each question, or each question is like broken down into how the marks are applied. And like, if you miss something, and it's like, well, you're wrong, but you're only a little bit wrong. Sometimes you might like hit run and your program doesn't even work, and you're thinking, well, I'm screwed. But if the code you submit is like, dude, all you have to do is that, and everything was right, well, you're not screwed, right? So you'll be in good shape there. It's not an all or nothing thing. And also, just because we hit run and you get the right output does not mean it's correct. So watch out for that. A lot of new programmers will say like, but I got the output. Well, it doesn't matter. You need to it needs to be correct all the time, right? Anyways. Yeah, so with this just loads it in. You don't need to get crazy with anything else. You don't need to write any extra code for loading it in. The only extra code you got to write for loading it in is just calling this function called load assignment 1 data. And, oops. And then down here, I really just want to emphasize that for this question, we see something called a loop, which we'll learn about today, but you don't need to know a lot about loops to understand what the idea is. It just basically means keep running this code some number of times. And if you look at the assignment 1 example, it's basically for each Starbucks location. We have a latitude and longitude that specifies a single point on Earth. And we also have the longitude, longitude, latitude, latitude that define the square. If the latitude, longitude point is within that square, you count it. If it's not, you do nothing. That's all I'll say about that. I don't want to spoil your fun, right? Okay, any last questions? Not really about, yeah. What do you, can you be more specific? You mean like, where is it? You mean like what this note tells you exactly? You just, like, you have to write it, because we need a function for that. But the data that you're loading in is already in decimal format, so you don't need to convert it. But if more data comes along, you might need to. So a good thing that function exists. Well, you don't need to convert anything to decimal, because the data you're getting already comes in decimal. Yeah. But maybe you're going to load another file that's not coming in decimal. Yeah. Yeah.
We define the parameter lat1 let's say part of the bottom corner, and like lat2 is part of the top corner. Would they, like, when the people who are marking, when they put in like different values to test our function, would they ever reverse the two, or?
They could, I guess, but I know what you're asking, right? Like, oh, do I need to make sure which one's the lower one? You could do that. Don't worry about it. That's not going to matter. But it's good that you're thinking of that. Okay, no more questions about the assignment. So if it's about the assignment, I'm not helping.
Is that like semi? Do you mark the assignment?
No.
Or is there a TA?
Oh, TA's mark. I don't mark anything.
Okay,
Yeah. Okie dokie. All right, class time. All right, loops. First, I've used this a bunch already. I know you have as well. Sometimes, like we can reuse variables. If you look here, we're saying A is 5, B is 6. Well, here, let's just take it and let's run it. Okay, A is 5. If I print out A, what should I see? Yell the answer. B is 6. Now print out A. What should I see? A equals A plus B. I print out A. What should I see? A is 3. A is A plus 1. I print out A. What should I see? 4. Good. See? Easy peasy. 5, 5, 11, 4. Perfect. You are all great at this. So, yeah, that's over. Also, by the way, I showed you this, I think, last class. Doing something like A equals A plus 1. That's like increment, basically count. If the number 7 will become 8 after that line of code runs. Code like that is so common that we have a shorthand for it. It's the plus equals. There's also minus equals if you want to do subtraction. You could also do multiplication equals, I believe, as well. Probably divide equals. I just don't use it if it exists. Let's do a quick test, see if it does. A equals 55. A divide equals 5. Yeah, all right. it works. That's interesting. Cool. So it's a shorthand for, this would be shorthand for A equals A divided by 5. You might say like, well, what's the big deal? It's just one letter. Well, yeah, but that's also a very bad variable name. If I had like number of equals number of Starbucks, you know, that's so much easier, right? So that's why we like it. In some other languages, you'll also see like plus plus. That's not in Python, but that would mean, that's shorthand for add 1. But if you ever wanted to add something more than 1, you'd have to do like plus equals 4 if you wanted to be like number Starbucks locations equals number Starbucks locations plus 4. So Python just doesn't have that one little thing. So if you've ever used plus plus and you're wondering why it's not there, well, it's not. Okay. Let's do a quick activity. Let's do it together just because we'll save time. If I say write a function add 1 to some variable 5 times, return the value. Okay, so oops. Let's go down here. Def add 1 arc sum and then I have to like add 1 to it 5 times. Now you might be saying, well, why would you do that? Just add 5 to it. No, don't. You have to add 1 5 times. Okay, so a var plus equals 1. Well, you know, 1, 2, 3, 4, 5. I just copy pasted and then return a var, I guess. And if I call this print some function and I'll give it 5, well, I hope to see 10. Perfect, looks good, right? Easy. Then I come back and say, all right, now do it again, but 10 times. Well, kind of annoying, but it's not too bad. I'll just copy these 5 and paste it. So if I call it with 5, now it should be 15. Okay, it works. Now do the same thing, but 100 times. All right, well, so that's 10 right here. So 10, 20, 30, 40, 50, 60, 70, 80, 90, 100. 105. Okay, it worked. Now do it, whatever that number is. Raise your hand if you just say, no, I'm not going to do that. Yeah, I'm not going to do that. Why would I do that? That's insane. That's silly. Maybe I can write a script that generates all those prints, but even if I were to do that, I would do it probably with a handy little tool called a loop. And if you've looked at assignment 1, you saw a loop. A loop just means run this chunk of code some number of times, like multiple times. It could be 0 times, it could be 1 time, it could be 175 times. Doesn't matter. It's a loop. So conditionals, we're really good at checking a condition, and if the condition is true, we do something. But we only do the something once. We can have a loop that checks a condition, and it'll keep running that loop until the condition isn't true anymore. So an easy example of this is this. Let's go down here. There. And I'm going to unindent that. Okay. So I'm starting A at 1. I am then saying, well, A is less than 11. That's kind of like an if statement. But because it's not if, because it's while, it means it's going to keep looping while that condition is true. As soon as that condition is not true anymore, as soon as this expression gives us back false, it stops. So what are we going to do? A is 1. While A is less than 11, print out A and then add 1 to A. And you know what? Let's be fancy and use what we just saw. Plus equals 1. Great. So let's work through this. I'm not even going to hit run. Let's work through this. A is 1. Well, A is less than 11. Is that true or false? True. Come on, wake up. It's Friday, but it's not the end of Friday. Is A less than 11? True. Then we increment A. So now we print out A. Then we make A 2. If we add 1 to it. And then we just go back up to the loop. A is now 2. Is 2 less than 11? All right, print it out, add 1. It's 3. Okay, yada, yada. A is now 9. Is A less than 11? Great, print it out, add 1. A is now 10. Is A less than 11? All right, print out 10, add 1. A is now 11. Is A less than 11? False. We stop. We jump down to line 5, there's nothing there. We go to line 6 and we print out A. What should we see on that last print there? 11, because A was 11. And you know what? Here. I am out of loop. Perfect. Any questions about that? This is it. This is a loop. Let's talk about generalizing it though. All this is a loop that will run if this condition's true. Any code inside of it will run. What code you like, whatever whatever code you want. You put it in there, it'll keep running, whatever that condition is true. What do you think will happen if I do this? Think about it for a second. I'm going to hit run. All right, yeah, stop. There we go. Oh, there we go. It kept running forever. Because the condition, the Boolean value for the while is true. Can true ever not be true? No. So we didn't have a way of like modifying a value inside the code to check that condition. Let's do another one. So let's go back to A less than 11. Okay, we run. Okay, looks good. Can you see this at the back still reasonably well? Cool. What do you think is going to happen if I do this? Don't yell out the answer. Take a second, think about it. You can all answer this question. I know you can. There's no trick to it. Just what does the code say? You can talk amongst yourselves. If you're struggling, I can guarantee you you're working too hard. You're thinking way too hard. Okay, raise your hand if you think you have an answer. Raise your hand if you have no idea. Okay, there's a bunch of people that I guess are in between. There is one trick to finding out the solution. It is, what does the code say? A is 1. Is A less than 11? Who said yes? True. So what do? Print out A. So we print out 1. Then we go back up. What is A currently? Is A less than 11? Print out A. Is A less than 11? This is going to act probably fairly similar to the last one, right? The only difference is, stop. The only difference is that we didn't count, but we still ran into this infinite loop. That loop would run forever. Because the condition, based on the code, the condition will always be true. A is set to 1. A never changes. So A being 1 is always less than 11. So it'll always run that code. All right, so now if I gave you this, it might be a lot easier, right? If I said write a function to do this. Okay, let's start with the 5. Let's go back up here. I'm just going to modify this one. Avar num counts. So here's what I'm going to do. I'm going to start, usually when you have a while loop and you want to like have it run some number of times and you know those number of times. Here what I'm going to do is I'm making the function such that it takes the variable we want to add to and then the number of counts, the number of times we'll add to it. When we have this, we're probably going to want a counter variable. And we'll start it at 0 this time, I guess. Then what I'll say, okay, while counter is less than num counts. Num counts will be the number of times I want to add 1. So if my counter, we're starting it at 0. If the counter is less than the number of times I want to run it, we run whatever's in the loop. And what is it that we want to do? We want to add 1 to our variable. So a var plus equals 1. So there we go. So this loop, as it's written, 0, 0 presumably will be less than whatever the parameter num counts is, and then we add 1 to it. So this loop will keep running and running and running. But we're missing a very critical thing. Who has an idea? Raise your hand if you have an idea of what am I missing? Why is this perhaps problematic? 2 people. Uh-oh. Let's see what happens if I call this. Oh, I didn't give it 10. So I had to stop it because the computer was kind of like stuck hanging. It wasn't doing anything. Look at this and think about what the problem is. And if you're looking for, I'm not looking for you to yell the answer out. If you're trying to find out what the problem is, again, there is one trick in computer science. What does the code say? Follow the code line by line, make no assumptions. Take a minute, talk amongst yourselves, and tell me what I'm missing. Go ahead, chat. And if you're really stuck, just tell me, just look at what the code says. All right, raise your hand if you think you have an idea about what it is. Really high, I want to see. Okay. What does the code say? Counter is 0. We have a bar num count, and in this example we have 5 and 10. So let's use 5 and 10 to run through this code and see why it just kind of hung there. Counter is 0. Is 0 less than num counts? Num counts is 10. Is 0 less than 10? Of course it is. So we add 1 to a bar. So a bar was 5. What does it become? All right, we finish the inside of the loop. We go back to line 3. We check the condition again. What value does counter have? 0. Is 0 less than 10? Did someone say sure? So that's still wrong. It's true. So, great, we go into a var again. And then we go up. Is counter less than 10? Will that condition ever not be true based on how this code is written? False. That's good. So I'm using this counter variable. I'm starting it at 0. And that counter variable, I'm making use of it to know how many, well, I'm not, but I should be, making use of it to keep track of how many times I've run the loop. If I start at 0, and I know I want to run it 10 times, so while counter is less than 10, what am I missing here? Someone yell it out.
You didn't increase the count.
Who said it over here? Say it again.
You didn't increase the count.
I didn't increase the count. What do I write then?
You replace the avar with count.
Oh, replace avar with count.
No, just
All right, go back, try again.
underneath it, you want to get, or, no, that's not, just,
Like that?
yeah, let's do that.
It's pretty good to me. Having that. Now, you may have noticed that I started my counter at 0 instead of 1. Who here like took note of that? Like, oh, why 0 not 1? Yeah. This is connected to what we talked about in labs about how computer scientists are funny and they start counting at 0. But also, if I started at 1, let's count how many times that loop would run if I set it to less than 10. So it starts at 1. Is 1 less than 10? Is 1 less than, or is 2 less than 10? Is 3 less than 10? 4, 5, 6, 7, 8, 9, 10. False. How many times did that loop run? 9. So if we start at 0, we can use the less than. You might say, well, just do this. Start it at 1, and then do that. Right? Yeah, that'll solve the problem. It does the same, effectively, yeah. It does the exact same thing. Now it starts at 1, but it'll go up to when counter is less than or equal to 10. So we can go that 10th time, which is great. But you got to remember, computer scientists are really lazy. And typing that extra equals, think of all the time you'll save if you never had to do that. So we like to start at 0 a lot of times. Don't worry, you don't have to. If this really angers you, sure, start at 1. I don't recommend it though, because in a couple of weeks, if not next week, we're going to want to start counting at 0 for other reasons. Raise your hand if you have an idea why. Raise your hand if you've ever done a caddis problem that where you had to read input from a list. What number do we use to access the thing at the beginning of a list? 0, not 1, right? Because those counts are kind of like offsets, not actually where they are, it's how much further I have to go. So I go to the beginning of the list, and how many steps do I have to take to get to the number I want? 0, why? Well, I'm at the beginning. 1, well, I take 1 step. Now I'm at the next thing. That's why. But the lists are for later. All right. So, now here's what we're going to do. I am going to give you a couple of minutes to tell me, and this right here is a perfect example of, like, I could totally put this on the midterm and expect you to get it. I realize the midterm is weeks away on the 20th or whatever, so this is the first time you're seeing it, but by then this should be easy peasy. So right now, don't expect it to be trivial, but I believe that you can tell me what this code is supposed to do, like what it effectively does. It's just a function, it's not being called with anything, but it might be easy to like try a few examples of it. Take a couple minutes and do it. Feel free to work together. I recommend doing it like pencil paper. If you don't have that, maybe open up Notepad and just keep notes of stuff, but yeah, have a go at this. As a hint, what I recommend is you keep track of the variables as you go. All right, raise your hand if you think you have an answer. Now, your answer can be one of two things. Your answer could be, like, I know what it's doing, or your answer could be, I know what it's doing, I can tell you a very precise thing that it is doing. Raise your hand if you've got the very precise thing that it is doing. Raise your hand if you see kind of the hint on the board about what the precise thing is. All right, fine. All right, so let's trace through it. Let's start with 5. Let's see what happens if we start with 5. 5's a good number, right? So 5, if n is 5, answer starts as 1. All right. Then, well, n is greater than 1. Well, 5 is greater than 1. Answer equals answer times n. So I'll just start with this going to, well, 1 times 5 is 5. And then, actually, no, here, we'll do 4 and then 5. Because we did answer equals answer times n. 1 times n, 1 times 5 is 5. And then we decreased n by 1. So that's why 5 went to 4. Is 4 greater than 1? True. So answer equals answer times n. So answer's 5, n is 4. What's 5 times 4? 20. And then we decrease answer. Then, I'm going to be a little lazy and just type the 2 now. But what is 20 times 3? Because n is still 3. I haven't really changed it to 2 yet. I just skipped ahead a line. 60. Okay, great. And n is 2 now. Is 2 greater than 1? True. All right, again, I'm just doing this to save myself going back. What's 60 times 2? 120. And then is 1 greater than 1? No. False. Good. So we return 120. Raise your hand if you found the pattern. Really high, I want to see. Raise your hand if you found the pattern by basically doing exactly that. Well, you should do exactly that, because that's a good way to do it. See what I mean? There is no trick other than what does the code say. What does the code say? And keep track of what the variables are, what the values are. If you do that, you're in great shape. Now, what is this though? What's that mean?
It takes the number and multiplies it by every number that's less than it up to 1.
Up to 1. So 5 factorial is 5 times 4 times 3 times 2 times 1, which is, of course, if you do it all, 120. So this is actually factorial, which is cool. Raise your hand if you're like, oh, I've heard of factorial before. Raise your hand if you haven't. You're the normal ones. Everyone else is the weird one. But factorial will come back. Computer scientists love factorial for a couple of reasons. Anyways, look at this here. Raise your hand if, yeah, it took you a couple of seconds to, or like maybe a minute or two to figure it out. Really high, I want to see. Yeah. If only someone just wrote in front of this function saying, this just does factorial. Wouldn't that be amazing? Too bad the programmer didn't write a comment. Or, too bad they didn't think of a better function name. Maybe factorial. Ah, bad programmers. All right. So there we go. This is just, wait, oh, this is me doing it with 4. All right, great. So let's end with this. Write a function called Int Sum that takes a single integer n as a parameter and returns the sum of all the numbers between 1 and n. And trace through it with Int Sum 5. Go ahead, do it. See if you can figure this one out. No, don't look at the solution. And if you're stuck, remember, I encourage you to chat with your neighbors. Yeah, well, okay, hold on. There's the real office hours, which is 10 to 11, Tuesday, Wednesday, Thursday, Friday. But then there's like office hours, which is just Twitch, and we like play video games, but you can show up and ask questions. But I mean, don't show up and ask, like, expect me to help you with assignment 1 in any detail other than quick questions, right? Because I'll be busy playing Minecraft or something. But of course, yeah, feel free to come. That's kind of why it's there. And what's cool too is sometimes, like if you come with questions, like other senior computer science students will be there, and sometimes they might just jump in and help, which is awesome. And so if you have questions about like upper year courses or anything too, they're great to ask. Raise your hand if you got it. Raise your hand if you totally will have it in like 30 more seconds. Raise your hand if you're like, oh my god, what the hell? Okay. What the trick is, slow down. What do we need to do? Okay, what do we got to do? We want to keep track of like a running total, basically. If I put in 5, I want the sum of all the numbers from 1 to 5. All right? So, here's what I'll do. I'll do total equals 0. Right? We start at 0. And we'll use the variable total to keep track of the running total. Okay? And I know I'm going to need a loop. Well, something is less than n, right? Oops. But the problem is, like in all the other cases, like down here with the a, and I'm missing that counter, a plus equals 1, I need a counter, but I can't really use total as my counter because total will grow a lot faster because it'll be 1 plus 2 plus 3 plus 4, not 1 plus 1 plus 1 plus 1. So an easy fix to this is make another variable. Don't be scared of getting crazy. Counter is 0. And we have counter is less than n. And I know whatever's in this body, great, plus equals 1. Great. So we've got that. But what do we want to do every time? Well, we'll say total plus equals, I guess, counter, right? We could just add counter to it. Because the first time through the loop, the counter will be 0. So 0 plus 0, whatever. Then it'll be 1. Okay, add 1. Then it'll be 2, add 2. Then it'll be 3, add 3, and so on. Now, there is one funny little problem with what I have here, though. This is what I would call an edge case. If I put in 5, it'll add up 0 plus 1 plus 2 plus 3 plus 4, but it won't include 5. So how could I fix this? There. Problem solved. That's it. All right, see ya. Don't jump on any ambulances or anything.